In the previous video, we learned what is electrostatic force and other type of contact and non-contact forces. In this video, we'll find out the magnitude of that electrostatic force that exists between two charges. Hello, it's me KIRAN Raj, and today we'll learn Coulomb's law. Using this law, we'll find out the magnitude of the electrostatic force between two charges. Before that, I would like to tell you that what is electrostatic force of repulsion and what is electrostatic force of attraction. For that, let me just take two charges. Two similar or like charges. Let's take a negative charge and the other one is of course a negative charge, because as I said before that we are going to take similar charges. Can you just tell me that what kind of electrostatic force is existing between them? Of course, this is electrostatic force of repulsion, because we know that two like charges will always repel each other while two unlike charges will always attract each other. Same for the positive charges. Now let's take two unlike charges. One is your negative charge and the other one is your positive charge, or the first is your positive and the second is your negative charge. The electrostatic force between these two charges is electrostatic force of attraction, because these two charges are attracting each other. This is the electrostatic force of attraction. I hope that this concept is very clear, because this concept is going to nail your Coulomb's law. Let's start what's Coulomb's law. Basically, the magnitude and the magnitude, or you can say the quantitative measurement of the Coulomb's electrostatic force was investigated by Charles Coulomb in 1884, and he put forward a law called Coulomb's law. In this law, he took two charges. Let's take a positive charge and the other one is negative charge. The force existing between these charges is your F. Now here we are going to find the magnitude of this F. This F. Fine. What is the statement of Coulomb's law? We'll understand this statement by just decomposing it into parts. He said that the magnitude of the electrostatic force is directly proportional to the product of magnitude of charges. We know that charges, this is Q1 and this is Q2. Now the first part of his statement says that this F is directly proportional to Q1 and Q2. Let's take this as equation number 1. Although it's not an equation, but let's just take this as our first proportionality. And in the second part, he said that this force is inversely proportional to the square of distance between these two charges. This is our second proportionality. Now, when we'll combine these two proportionalities, we'll get F is directly proportional to Q1, Q2 upon R square. Now, to remove this proportionality sign, we need a constant. This constant is called K. This is called Coulomb's constant. Remember one thing, that K always depends on medium. If it's air, so the value of K will vary. If it's vacuum, so the value of K is constant, that we are going to calculate in the next slide. But before that, you must have to remember one thing, that K's value vary from medium to medium. Now let's calculate the value of K. That how to calculate the value of K? As you can see, here we are going to find the value of K. How to find the value of K? We'll find the value of K using this equation. K is equal to 1 upon 4 pi epsilon naught. Wait, I'll make you understand each term one by one. We know that 3.142 is the value of pi, so this is 4 pi. Epsilon naught. Now what's this? Basically, epsilon naught is called the permittivity of free space. It is a constant. This constant depends on medium. This is called epsilon naught. Fine. The epsilon naught's value is always a constant. The value of epsilon naught is 8.85 multiplied by 10 raised to power minus 12 Coulomb square per Newton meter square. Don't confuse yourself with the units of K and epsilon naught, because they are different from each other. So epsilon naught value is 8.85 multiplied by 10 raised to power minus 12 coulomb square per Newton meter square. Now, when you'll put the value of pi and epsilon naught in this equation, so you'll get the value of k. I've already calculated the value of k on this page, but if you wanted to calculate it by yourself, so you can also do that, but the value will always be a constant. This is the value of k. It says 9 multiplied by 10 raised to power 9 Newton meter square per Coulomb square. This is the value of k. Remember one thing, that this is the value of k in vacuum. As I said before, that k always depends on medium. It means that the value of k will not be 9 multiplied by 10 raised to power 9 Newton meter square per Coulomb square in any other medium like water, air or glass. But how to calculate the value of k in any medium like water, glass or air? For that, you have to introduce another constant, that is your ER. Now what is this? ER is called dielectric constant. This is another constant which is important or required to calculate the value of k in any other medium. This is also called relative permittivity. How to calculate the value of ER? For that, you just have to, let me just make it very clear to you that k is equal to it will be F is equal to k Q1 Q2 upon R square. Now we know that if we introduce any kind of a medium between two charges, suppose that I'm introducing any kind of an insulator between two charges, so that insulator will be ER. Now by introducing a medium or ER, the magnitude of this force, the magnitude of the electrostatic force will be reduced. That means that I am going to introduce ER in the denominator of the equation. Now your equation will be F is equal to k Q1 Q2 upon R square. Here we'll introduce another equation, that is ER. Now this ER will help us to find the F in any medium like water, air or glass. And if you wanted to put the value of k in this equation, so it will be F is equal to, we know that k is equal to 1 upon epsilon naught and multiplied by 4 pi. So let's just put that value, 4 pi epsilon naught multiplied by Q1 Q2 upon R square. This is the equation that will be used to calculate the value of electrostatic force in vacuum. But for medium, we'll introduce ER here. This is a very simple basic equation of calculating the value of electrostatic force between medium. If you wanted to say medium, so introduce ER, but if you wanted to calculate it in the vacuum, so just remove the ER. I hope that you got something out of it. Thank you so much. In the next video, we'll see what is electric field intensity and electric field lines. Thank you.